When the applied force is on an angle, we have to do component work to figure out the normal force and the component of the F applied that will plug into the horizontal. An extra step with the components, but otherwise it's the same as we've done before. Draw the free body diagram. In this case, my applied force is on the 60-degree angle. So the 60 would fit in here. And I know that it's 25 newtons in size. There's going to be a gravity force pulling it straight down, a normal force reacting to what's going on vertically, it'll be straight up, and a friction force backwards. We're kind of taking a step backwards. Since it's accelerating horizontally, we need the horizontal component of the applied force and the vertical component of the applied force. The vertical component opposite the 60 is a SOHCAHTOA, so that's a sine relationship. This side will be 25 sine of 60. The horizontal component adjacent to the angle will be 25 cosine of 60. We start with the vertical. We need the normal so that we can work with the coefficient. Looking at the vertical, it's not a boring case. Whatever's happening in the up direction is completely canceled out by what's acting in the down direction. In this case, we've got two upward forces. The normal force is upward, and the 25 sine 60 is upwards. The only downward force is gravity. We're looking for normal force, so if I flip it around, normal force is going to be gravity, the mg. This time, take away 25 sine 60. Now we can crunch it out. The mass of this was 5, g is 9.8. 25 sine 60 is like 0.87 or so that's going to be kind of a funny decimal. When I worked it out, I got 27.3 as a normal force. That's what we'll carry forward as we move into the horizontal. Horizontally, it's accelerating, so I'm setting up F net equals ma. We've got a tug of war going. The forward force is winning. The 25 cos 60 is bigger, so I'm going to make that the positive. Friction's backwards, so it's a negative, and that's equal to m times a. 25 cos 60, we could get that as a decimal anytime. It's a little bit clean. Cosine of 60 is a special one. It's 0.5. Friction is always mu times Fn, and that's equal to ma. At this point, I know everything but the a value. We're solving for a. So 25 cos 60, we could do the math on that. I think it ends up being 12.5. Don't know the mu. We do know the mu. Forgot which question I was doing. The mu in this case was 0.2. Yeah, the mu is 0.2. The normal, we just did the math to figure out, is 27.3. The mass was 5, and we're going to solve that for a. I'll let you double check the math. If I didn't make a mistake, I got 1.4 as the acceleration of that one.